Okay, so last time we did rectangular tank, right? I will go to the same rectangular tank. So today I will continue with the concrete design for it. Okay. Okay, so we did analysis successful, right? So that we can go for design. The load and combination, what we taken. We don't take an load combination. I will go for this is for definition, right? Not definition. I will go for load case detail, add. I will go for auto load combination in the sense we have some regional codes. Okay, so for example, ACI, generate loads. So we can also select which table. So you need to refer the code book so that we can, for example, if I'm considering table 8, so it should not take blindfoldly. You need to study and accordingly you can take. So it is generating automatically the load combinations. Okay, and this load combination we can edit also. For example, here you can click and we can edit the load combination. See, this is auto load combination. Later that we can also like edit it. Okay, now we can analyze and we can see that anyway it will be successful. Before itself it was successful, right? Okay, so we can stay in modeling mode. Okay, this load combination having all three loads and also with factor, it's good. Okay, now we can go to design here. Can you see the design tab in page controls? This is called page control, we used to call. But in the Connect edition, this page control shifted here. Horizontally, it's shifted. What we have the tabs, this it coming vertical. Okay, the page control, I click design. And in the design, we are going for concrete design since it's like a concrete structure. So click the concrete design and you need to define parameters. When you click define parameter, so many parameters you are getting. So this much parameter not needed for all. Okay, we can select the parameters. Okay, so first of all, we need to go to select parameter and I will select everything this way and we can select what are all the things we want. For example, compressive strength is very important for any concrete structure. And like then Fi main yield strength and then Fi secondary. This is for main stirrup, and this is for the main reinforcement, and this is for the stirrups. Like stirrups we used to have, right? That's what it is. And we can also select the minimum main and maximum main, minimum secondary, and all. Okay, the click OK. So only we selected the parameters, and those parameters we can put assign. So I will consider this is like a concrete structure. Now I will consider M30 grade of concrete, 30,000. Add it and Fi main 415 steel, right? 415000. If it is not this round number, like if it is like this, you will get warning. Otherwise, you can continue with that also. But 415 grade of steel. Maximum main, you can select from any of the sizes. Okay. So maximum main reinforcement, like I will consider so 20. Okay, add. So minimum main, I will consider 12. Okay, and minimum secondary, I will consider 8 mm. Okay, so now we added everything. So it is showing question mark. So you need to assign everything. So you need to assign to view, assign to view, assign to view because everything is concrete. Assign to view. It will assign to all the things. Okay, assign to view. Assign to view. And we are just taking based on the ACI code. We can also select any of the other regional code. For example, IS 456 for Indian codes. So all three India only. Now you might be aware of IS 456. That is like a concrete code book. But this is like American code book ACI. We also have British code book that where we have BS or something. It will start with B like that. CBS, like the British courts, American courts, Indian courts, and other courts also we have. Okay, now we are just doing the concrete design based on the ACI code. Okay, now we selected the parameter and we define the parameter. Now we need to go for commands. The commands is very important. So what we can do means like we need to design everything. I'm going for design beam add, design column add. First we are adding slab or element add, takeoff, so that you can see the quantity takeoff. Okay, now you will be having question mark. Quantity take, it will be automatically assigned. Okay, but everything else. So design beam, what we can do means like go to select beam parallel to X, select beam parallel to Z. So design beam and assign to selected beam. These are all the beams, right? Okay. So then design column. So select beam parallel to Y we need to select. Okay, assign to selected beams. Then design element, assign to view. Because we have plates, so assign to view, it's better. Okay, now it should be like this. Now we can analyze. So we will get the concrete design. But before analysis, uh, see, if I am just clicking here, you can't see the concrete design. After deflection, concrete design is missing. But only after the successful analysis, you will get the concrete design there. See, we are getting zero error, zero warning. It's good. I will go to view output file. Done. So we can see that takeoff concrete. See, you can see 41.1 cubic meter of concrete is needed. And we also want this four sizes of reinforcement, this much in LBS. Why it's showing in LBS? Because we consider American code book. Now that's why it's an LBS. Otherwise, if you're considering Indian code book, then it will be in ton, metric tons like that. Now this much 3392 total LBS we need, and separately 8 mm bar, this much 12 mm bar, this much 16 mm bar, this much 20 mm bar, this much. This is what the concrete design. So we are getting the quantity for concrete and also for the reinforcements. And apart from that, results also we can see. And we can see the concrete design here, and you can see beam number 2. See how much you want. Everything it's showing here. And you can also see the reinforcement. Fixed number of 16 mm bar, 5 number of 12 mm bar. You can also see the cross-sectional details for the reinforcements. Okay. And see 23 number of 8 mm stirrups at 149 center to center. You are getting the whole beam design, right? This is for beam. And we can also go for column. I think this is for column. Wait a minute. This is beam only. We can scroll down and we can see the column also. Control F and you can go for column, design column. Yeah, you can see the column number 1. See, it is showing 4 number of 20 mm bar. Okay, and you can also see the see 45415 FC30. Why we are getting this one? What are all the value you are putting? It will consider. So 30 megapascal compressive strength concrete and 415 grade of steel, and you can see the size of the column. Only minimum steel is required. Area of steel required also they are showing, and you can also see here how it's worked out. And you can also see the tie bars also 8 mm, spacing 320 mm. Okay, center to center, everything. So the in column we can call that is tie bar. In beam we can call this that is stirrups or tie bars. Okay. So that one, like you can double click here and you can see here. See. So here you can see even more easily. You can understand. So so see here even more like a pictorial representation showing the stirrups and all. What are all the things you are seeing there? Here also you can see. So very simple, but you need to do everything in a right manner so that your concrete design will be successful. So here we will see how much the concrete design. This is 20 cross 4 only. But for the slab, we are not getting the exact number. For the slab, what we can do means like I can go to STAAD output, Control F. I can put element. See element design summary. You can see this is showing top longitudinal direction, only minimum steel required. A transverse direction, both the direction we have, not transverse and longitudinal in the slab. So the bars. So they are just telling only minimum steel required. Okay, which means like the cover also they are telling 19.05 mm cover should be provided, thickness 150 mm, and you can also see the concrete and steel grade, and you can see the area of steel required. So 0.135 like that. So minimum steel required in the sense you can go with the 8 mm bar. So 8 mm bar is more than enough. That's why they stated only minimum steel required. Okay. And this is like the area of steel required. So you can go with the minimum steel required, and you can find the center to center based on the area of steel required. Okay. So the element design summary will be like this only. But for beams and column, we can able to click and see. Exactly, we can click and see the things. Okay. So are you okay with the concrete design? Like this, you can do for any structure. Now we did for the rectangular water tank or rectangular overhead water tank. We can do for any structure. Okay, for buildings and all. So all three, are you okay with the concrete design?
Yeah.
Okay, sir.
Okay, you don't have any doubts, right?
No doubts for
Nothing
now.
from my side.
While practice, maybe.
Okay. So do you want me to continue more topic today, or you want to practice this first time? Because very important, concrete design. So just practice. Even in
Yeah, yeah,
fact, in
that
the
will be
real
good.
time, like they will put even more parameter. I consider it very important parameter. They will consider even more parameter. For that parameter, you need to put in a some sequence. Otherwise, like you will get some warning error like that. So just go through everything so that you will get some idea. Okay, so concrete design is very important. Okay,
Yeah.
so do you want me to do another concrete design for some other structure, not this water tank? We will go with some other building structure.
Yeah, that works. Yeah.
Okay, so in that case, like I will close this, and I can go to I think seismic. We did seismic, na?
Can we do like stairs or any such things in this?
Stairs. So stairs,
Yeah,
like
yeah.
normally we used to put only yeah. Okay. For stair, it is very different. So what we need to do is, see, I will get one example, good example. I don't have that book with me now. So where like otherwise like, hmm, do you want me to do the stair now?
Yeah, if possible, we can do that.
Yeah. Otherwise, like, wait a minute. First, we will close this, and then we can go back to the seismic one we did. See the seismic one we did, right? For that, I will do concrete design. Very simple. Now this analysis already successful. Very simple design. Design concrete, and now at this time I will go with the Indian code because we seen the ACI code. Now I will go with Indian code. Do you want me to go with British codes? I can go
No,
to this
Indian is
one.
fine. So we'll know the concrete quantity and steel quantity only.
Uh, so Indian, I will select IS 456. So accordingly, this also it will vary. FC and FY main I will consider. Yeah, mostly every code book it will be having the same one. Maximum main we have, maximum secondary we have, minimum main, minimum secondary. Yeah, like that we can take. And something else, if you want, also you can take it. Okay, define parameter. So this also I can go with 30 grade because a big structure. We can go with more strength. So here it is easy for us. So before we are just entering now, but in Indian code book they are asking to select maximum size of main reinforcement. I will go with the 40 mm. Okay, maximum secondary I will go with the 12 mm. Minimum main I will go with the 10. They are already suggesting 10 only. Minimum secondary I will go with 8. They are by default they are suggesting the right one. Okay, I think this one we can assign to view. So which means like it will assign to the whole view. So question mark should not be there so that you will get error. Okay, assign to view. Okay, so commands. So what we can do means like if I'm going now, see the other way, no problem. We will first add everything and then we can come back. That is good. We can directly assign also, but that might be confusing for you. But we don't have slab, I guess. Okay, so take off. So select beam parallel to X, select beam parallel to Z. So both it will be selected assigned to selected beam. This is important. You should not assign to view. Column should be for vertical alone. Assign to view, assign to selected beams. Okay, so I think element was not there. We will see assign to view. There is no element. So what we can do is we can delete it. Okay, so now we can analyze only for beams and columns since we don't have the element there. We have more members now. It may take a little time. See, after seismic, after wind, and only you need to go for concrete design, not well in before. Okay. So it is showing the beam design, concrete design separately. You can see it is showing the area of steel required. It is different from the previous one. Can you see? In previous, they are showing the representation, but here they are just providing the area of steel required. This is what column also we got. Suddenly it came. See column you can see, and you can see this is PUZ value. In Indian code books, like the PUZ value and all very important for any column. See, they are telling main reinforcement provide 24 16 24 number of 16 mm bar, okay, equally distributed, and 8 mm dia bar at 255 center to center. So each code book showing the results differently. Okay, and you can see the concrete design. Takeoff, where the takeoff? You can scroll down and we can see the takeoff. See in the bottom, you don't have takeoff separately, but here you can see total volume of concrete 1043 cubic meter. And here you can see everything in ton, maybe even it might be mm, weight in newton. New, why it is showing in new? This will be, I think, you need to consider 641 ton, something like that. Okay. Now you got right. We also done the Indian code book kind of concrete design. Okay, so when you close it, you can directly double click and we can see. You can see here 16. This is like see 20 size is 12, but 20 number of 12 bar. But here we can see only 8 number of 12 bars. It's considering only 12 bar since we not gave that much weight. Now that's why for this weight, for this condition, this is enough. That's why it is taking 12 bar, but the numbers getting varied. Can you see here the top? It is getting only 8, but in the middle and all, like it might be more. See here it is 8 also. Maybe only in the below. See here also 8. So only here it is having more. So it's good for the structure. So we can also go with reducing the number of bars and increasing the size of bar. That also we can go. So that when you are defining the parameter, you can remove that thing, or you can put minimum, not 12, minimum minimum main 10, right? You can put minimum main itself 20 like that. Accordingly, you will get here. Okay, you got it. You got the point, right? If I am putting minimum main 20, assign, close. Now we will analyze. We will see how the outcome. Before it was 10, that's why it's taken 12. But now we are putting 20. Maybe it will take 20 or more than that. See, now you can see here it's getting varied. Now you can see only 20. Okay. So accordingly, you can see the concrete design happen. See here it is showing 8 number of 20 bar. Before it was 20 number of 12 bar. That is the difference. Maybe now it was here 8 number of 20 bar. Everywhere it is coming same. Okay, but here what we can see. See here it is different for beams. You can see the things here. Okay, and what about here? So 2 number of 20, 12 number of 8 as stirrup. So 3 number of 20 like that. You can see the representations. Okay, now you are okay with concrete design, right? How to check the reinforcements and all.